All right, welcome to this Computer Science A multiple choice questions video. I just pulled these questions from this website. These are just sample questions from the College Board. They typically do not release the multiple choice questions each year. So if you want to follow along with this test, I'll link it in the description. This first problem says, consider the following code segment for int k equals 0, k is less than 20, and then k is equal to k plus 2. If k modulo 3 is equal to 1, we're going to print out k. So I think with this problem, it's like for loops in general. A lot of people just want to jump into the problem right away and start solving for it. I think it makes sense to sort of take a step back and consider what our bounds are and what we're looking for. Okay, so with a lot of for loops, you'll see that we go from 0 to some number and then we do like k plus plus. But in this problem, we're doing k plus 2. We're effectively skipping every other k. So if we were to plot this on a number line, we're going from k is equal to 0 to k is equal to 20, not inclusive. So we're never going to actually reach 20. And then in between that, we're going to be jumping 2. So we're going to go from 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Okay. And then it says if k mod 3 is equal to 1, then we're going to print out k. So what does k mod 3 equals 1 mean? Well, that means that if we were to divide k by 3, we would get some number and then a remainder of 1. So this effectively means that k is not fully divisible by 3. We would expect it to be some number divisible by 3 plus 1. So let's think about what numbers are divisible by 3 from 0. Technically, 0 is divisible by 3. Then we have 3, we've got 6, 9, 12, 15, 18, then the next number is going to be 21. So we're not going to include that because that's not within our bounds. If k mod 3 is equal to 1, that means that we're basically just adding 1 to whatever number is divisible by 3. So if we have 4, 7, 10, 13, 16, 19. So now we see if any of these match up with the numbers that we're going to get within our number line. So it looks like we have 4 and 4, we have 10 and 10, and we have 16 and 16. So I would say that the correct answer here would be B, 4, 10, and 16. The way that I solve this, you don't necessarily have to solve it. You could also just go through every single number and see if k mod 3 is equal to 1. You can do that as well. So like if we were to do that, we got rid of this. 0 mod 3 is not equal to 1. It's equal to 0. So we wouldn't use 0. If we did 2 mod 3, we would get 2 as our remainder. It wouldn't be 2 either. 4 mod 3, well, if you divided 4 by 3, you would get 1 and then a remainder of 1. So this one would actually work out in our favor. So we know that we're going to have 4, so we can actually just effectively get rid of C, D, and E. So now, like, if you wanted to save up on some time, you could check if 10 is mod 3 is going to be equal to 1, and if it is one within our bounds that we're going to be looking at, and that would help you out. So either one of these ways is a good way to solve this problem. Let's go ahead and move on to the next problem. It says, consider the following code segment. So we're creating a list of animals, and then we're adding stuff, we're setting something, and then we're adding, and we're also removing as well. So remember with these problems, you also have the Java quick reference. Specifically, we're going to be wanting to look at the ArrayList quick reference methods. We're adding a few things. Remember, there's 2 different add methods within the ArrayList class. The first one, you just add it to the end of the list. You don't specify an index. The second one, you do actually specify an index. And it looks like for these first 3 add methods, we're just basically adding it to the end of the list because we don't have that index. So let me label these. So after the first line, we are just going to have dog inside of our array list. The second line, we are adding cat to the end of it. So we have dog and cat. Third line, we have dog, cat, and snake. All right. The fourth one is a little bit tricky, but remember you have that Java quick reference. So it says that the set method, so it replaces the element position index with object. So we're going to find where the second index of our array list is. So remember, we're doing 0 indexing. So this is our 0 index, this is our first index, this is our second index. So what we're doing with line number 4 is we are setting snake to now be lizard. Okay, so that's what the state of our list looks like now. With line number 5, we're using the other add method, the one that specifies that index, and it says that it will insert whatever object you're passing in at position index and then moving elements at position index and higher to the right. So we still have dog for the first element in our array list, but now everything that was included, everything that was at index 1 or above is going to be shifted 1 to the right to accommodate for the fish that we're adding at index 1. So now this is what our array list looks like. Okay. Line number 6, we're now removing an object. So the remove method says it removes an element from position index, moving elements at position index plus 1 higher to the left. So basically, what is at index 3? At index 3, it's lizard, so we get rid of this. So now what's left in our array list is dog, fish, cat. So then when we print out animals, it's going to print out dog, fish, cat, which is answer number A. Answer B is incorrect. Remember that we removed the lizard because that was at index 3. That's wrong. Answer C is also incorrect. I think this might have happened if instead of setting at index 2, you set it lizard to be at index 1. That's the case that would happen. And then fish, dog, cat, this is just, I think you might have gotten this if for line 5 you set fish to be at index 0 instead of index 1. And then throws an array index out of bounds exception. This isn't true. All of the indices that we were given for set and remove were valid. If, for example, we had said like animals.set, I don't know, like 100 or something, and then some like other animal, say a horse, then we probably would have gotten an array index out of bounds exception. That one is not true as well. Moving on to the next statement, we're being told that we have this mystery method and it passes in some list of integers, and we are being told that we're looping from 0 to nums.size, k++, and then we get the value at k within that list, and we remove the value if it is equal to 0. So with this problem, make sure you are looking very, very closely at your bounds. So we see that the bounds start at k equals 0, and then it goes until k is less than nums.size, and we increment our k each time we go through the loop. Something to be very, very aware of when you have a for loop and you're removing elements from it is that our nums.size is going to be dynamic. So typically when you're doing a for loop, you anticipate that like if nums.size was 10 at the beginning of the for loop, you would also anticipate that nums.size would be 10 at the end of the for loop as well. However, since we're removing things, it's possible that like halfway through the for loop, our nums.size is now 8. So we might actually end up skipping over certain indices based on what our k is and based on what our current size is. Every time we go back to the top of our for loop and we compare int k to nums.size, we're recalculating nums.size, so it has a potential to be different. Okay, so just keep that in mind. We're being told that the nums that's being passed in is this list, and it has 8 values inside of it. So for our bounds, the first loop is going to be k is equal to 0, k is less than 8, and then k++. We get nums.get at k, so that's at 0, .int value. So don't be too scared of this .int value. Maybe you have never seen it before. You're basically just converting from an integer to an int. You can find this within the Java quick reference. And then you're comparing that to see if that is equal to 0. So for our list, we have, here's our list. Let me add our indices. Index 0, 1, 2, 3, 4, 5, 6, 7. So basically we're comparing whether this value is equal to 0, and it does. So what we're going to do is we're actually going to remove it from our list. Okay, this is where things get a little bit crazy with nums.size. So this is no longer in our list. So we can go ahead and just erase it, I guess. So what does that do to our nums.size? Okay, so now we're going to increment our k. So our k is now 1. Our nums.size, we have one fewer number within our array list. Okay, we have 7 now. So we're actually also going to update this. If, for example, we had saved nums.size as a variable outside of our for loop, then we wouldn't be recalculating it. But the fact that we're saying k has to be less than nums.size inside of the for loop header, that means we're going to keep recalculating it. And it's actually good that this doesn't happen because we would get an array index out of bounds, probably, since we're removing stuff. But anyway, so we update our upper bound of our for loop. We're also going to be updating our indices, right? So since there's no longer a 0, since we got rid of the first 0 at the start of our loop, now our indices have changed as well. So this is what our new nums list looks like. Okay, so now that we've updated our k, we're going to also run the inside of the for loop again. So is nums at get1.int value equal to 0? So you might anticipate that we would start looking at the next number in our array list. You'd be incorrect. And the reason why is because we're not setting our k back equal to 0, back to the first value within our array list. We're looking at the next k value. And the next k value is actually going to be at index 1, which is going to be that 4. So we're effectively looking at that 4. And does that 4 equal 0? No, it does not. So for this instance of the loop, we're actually not going to remove anything from our list. Next, we're going to update our k again. So k is equal to 2. Our size has not changed. It still has 7 values inside of it. So we're still comparing it. Is it less than 7? Yes, it is. So now we're getting the number at index 2. So that would be this number here. This also does not equal 0. So we're going to move on to the next k. So that would be 3. We're updating the value inside of our statement. So now we're looking at index 3. Index 3 is 5, also not equal to 0, so we're going to update our k again. So now we're at index 4. So we're looking at this number now. This does actually equal to 0, so what we're going to do is we're going to remove it from our list again. So this no longer exists. When we increment, we're going to have to update nums.size. So nums.size, we now only have 6 numbers inside of our array list, so we're going to have to make this 6 instead of 7. And also all our indices are going to change. So we remove the value at index 4. So now our 3 is at index 4 and our 0 is at index 5. Notice also that we're not changing the indices of any numbers that were before what we removed. Those should stay the same. Make sure you don't update those as well. Okay, so now we're looking at the number at index 5. So once again, notice we skipped over that 3. We're just not taking a look at it. It's kind of like the middle child, maybe. Okay, so we're looking at index 5. At index 5, we do have a 0, so we're going to be removing it. So now we don't have that number. We try to increment our k, so now this is 6. We recalculate the nums.size, which is now 5. We only have 5 numbers left in our array list. So because 6 is not less than 5, we're not going to keep moving on with the for loop. So this is the final state of our array list. So I'm going to get rid of this index as well. So it looks like our final array list has 5 numbers inside of it. So this most closely matches up with answer D. Solution A is incorrect. This is just if you didn't remove anything from the array list. This is obviously not the case, as I just showed. B is also not correct. You'll notice it's missing the first 0, but it's the same as D otherwise. This would be incorrect. This would be if you hadn't noticed that we had moved on to index 1 after the first 0 was removed. This would be if you thought we went back to k equals 0 when we incremented our k and we removed this as well. So that one is incorrect as well. C is incorrect. I'm not really sure how you would get this one if you moved all of the zeros to the front, I think. That is not what is happening in this mystery method. E is also incorrect. So this might have happened if you did what I said earlier, where you set some variable equal to nums.size and then you were using that instead of recalculating it as you were removing numbers from the list. But that's not true. Since we keep our bounds updated as we remove stuff, we're not going to get an index out of bounds exception. Moving on to the next problem, we get at a certain high school, students receive letter grades based on the following scale. So then you get 93 or above, that's an A. If you get from 84 to 92, that's a B. 75 to 83, that's a C, and then below 75 is an F. We're being told which of the following code segments will assign the correct string to grade for the given integer score. And we get 3 different code segments, and we're being given an option between combining, 1 and 2, 2 only, 3 only, etc., etc. So let's go ahead and understand what we're doing here. So if we set up a scale again, we have 75, 83, 84, 92, 93, and then below 75 is an F. 75 to 83 inclusive, so this is a C. 84 to 92 inclusive is a B, and then 93 and above is an A. I guess they don't have D's in this school. So let's go ahead and just look at the first code segment to see if this gives us what we want. So it says if the score is greater than or equal to 93, the grade will be A. So that seems to check out here, yeah. So notice it says 93 or above, so it's saying 93 inclusive or greater. So that's exactly true. It's going to give us an A. So now it has a separate if statement for B. It says if it's greater than or equal to 84 and less than or equal to 92, you're going to get a B. So that's also true. And you'll notice that it's not actually possible for if you had gone into this first if statement to go into the second if statement, because let's say, for example, we got a 95. It's not going to be true that we got a score greater than or equal to 93, and we also got a score that fits within the B range. Okay, so it's okay that these are separate if statements because we're checking the upper bounds of our score. So that second if statement seems to work out as well. Our third one is for C. It says if it's greater than or equal to 75 and it's less than or equal to 83, you're going to get a C. That's also true. That fits up with what we would expect. And once again, we have that upper bound and we have that lower bound to make sure that we're not going to give it too low or too high of a score. And then we have if score is less than 75, we're going to get an F. So at this point, we've included all the ranges for scores higher than that. We know that if you get a 60, you're going to get an F. There's no way that you could have gotten a score of 60 and gotten any grade other than an F given this structure. So I'd go ahead and say that code segment 1 is good. It checks out. So for any solution that doesn't include code segment 1, that would be incorrect. You can go ahead and eliminate those right now. So 2 only and 3 only, those do not work. So now we have 3 left over. So if, for example, you were crunched for time, you didn't have time to look at the other code segments, at least you have a greater chance of selecting the right answer. So let's look ahead at code segment 2. Very, very similar to code segment 1, but now we're doing something a little bit wild. So first statement is exactly the same. It's saying if its score is greater than or equal to 93, you're gonna get an A. So that works out. I would say that seems reasonable. If you got a 97, you're gonna get an A. Then, however, we do something a little bit funky. We say if the score is between 84 and 92, then we're gonna give them a B. This, unfortunately, is not proper syntax. You can't set up an expression like this. It has to be like this, where you have a lower bound, the double ampersand, and an upper bound. What you're actually going to get, I think, if you try to run this in Java is, so 84 is less than or equal to score. Let's say that it's going to give you some sort of Boolean, so either true or false. And then you're going to compare true or false is less than or equal to 92. And Java is going to be like, wait, you're trying to compare something that's a number to a Boolean. That's not going to work out. So this is just going to fail. So this is going to fail just based on syntax. It's not even worth looking at the other if statements. This is also not going to work out because of that syntax. So we can go ahead and eliminate anything that has 2 in it. So 1 and 2 only will not work as well, and E will also not work. So we're only actually left with one answer. You can go ahead and circle that if you want, but I'm going to go ahead and make sure that code segment 3 works as well, just for peace of mind. All right, so code segment 3 hypothetically should work, but let's go ahead and test it. It says that if the score is greater than or equal to 93, we're going to get an A. That looks great. That is exactly the same as code segment 1. Then it has an else if. So this is different than code segment 1 because we're not comparing that upper bound. But that's not a problem. Why is that not a problem? Say, for example, that a student got a 97. Well, based on the order of this if statement, they would be placed into that A range, okay? So it's not actually possible for us to reach a B grade if a student got a score of greater than or equal to 93 because it would already go into the A if statement, right? So else if assumes that it did not go into the if statement above it. So the only way we would get here is if we had a score that was less than 93 and also a score that was greater than or equal to 84. So that would be that B range. So that would work out for us. We're applying that same exact concept for the C grade. So you might say, oh, it's a problem. We're not checking the higher bound. Well, let's say that our student got an 85. We wouldn't get an A because it's not greater than or equal to 93, but it is greater than or equal to an 84, so we would have gotten a B for that student. We wouldn't get a C because we would no longer have to check the other conditions since they're all else ifs. So the same condition applies for C, and that works out. If by the point you get to your final else statement, you have to know that this score has to be less than 75. The reason why is it didn't go into any of the other conditions, okay? So our F works out as well. So we know that that is the correct answer here. Hopefully this helps you out with these AP Comp Sci multiple choice questions. If you have any questions, feel free to leave them down below and I'll get back to you. And I hope you have a great rest of your day.